Have you ever wondered how humans send satellites to other planets? How do we measure the vast distances of space and guide our machines across millions of kilometers? In this video, we focus on 5 planets: Earth, Mars, Venus, Jupiter, and Saturn. These planets have all been orbited by human-made satellites. The remaining 3 planets, Mercury, Uranus, and Neptune, have either only been visited briefly by spacecraft flybys or present extreme conditions making orbiting difficult. Here we are on Earth, our home planet. Thousands of satellites circle around us in low Earth orbit, helping with communication, weather, and science. Look at the orbit lines and imagine how far above our heads these satellites are. Now, let's travel to Mars. Satellites orbit the red planet, studying its surface and atmosphere. Mars is between 56 and 400 million kilometers away from Earth, depending on their positions. These orbiters help us understand Mars like never before. Next is Venus, shrouded in thick clouds. Human-made satellites have orbited Venus, revealing its extreme heat and dense atmosphere. Despite the harsh environment, we have learned a lot from these missions. Farther out is Jupiter, the largest planet in our solar system. The Juno spacecraft orbits Jupiter, studying its massive storms and magnetic fields. Imagine the sheer scale of this planet compared to Earth. Finally, we arrive at Saturn with its majestic rings. The Cassini mission spent over a decade orbiting Saturn, exploring its rings and moons. These missions show how far human technology can reach in space. Sending a satellite to another planet is not easy. Engineers must calculate the perfect trajectory to reach the target planet, taking into account the gravity of the Sun and other planets. Powerful rockets are needed to escape Earth's gravity and accelerate the spacecraft to high speeds. Even tiny errors can make a spacecraft miss its destination by millions of kilometers. This is why only a few planets, like Mars, Venus, Jupiter, and Saturn, have orbiters. Mars has several orbiters circling it right now. These spacecraft map the planet, study its climate, and search for signs of water. Without orbiters, long-term exploration of Mars would be almost impossible. As we move farther from the Sun, missions become more difficult. Saturn had a long-term orbiter called Cassini. But Uranus and Neptune have only been visited by flyby missions. No orbiter has ever entered Neptune's orbit. Have you ever wondered how humans communicate with satellites millions or even billions of kilometers away? When a spacecraft reaches another planet, it does not work alone. In most missions, an orbiter is sent to rotate around the planet. This orbiter acts as a communication satellite. Rovers and landers on the planet's surface cannot send data directly to Earth. Instead, they transmit signals to the orbiter above them. The orbiter then relays this information back to Earth. Communicating with satellites around other planets is extremely difficult. Radio signals travel at the speed of light, but even then, they take minutes or hours to arrive. For example, signals from Mars can take between 4 and 24 minutes to reach Earth. This means real-time control is impossible. Engineers must design spacecraft to work independently. Every command, every signal, and every piece of data must be carefully planned. This is why orbiting satellites are critical. They are the invisible communication bridge between Earth and distant worlds. ACE is an extraordinary challenge, both scientifically and financially. The cost depends on the launch vehicle and the target orbit. For example, sending a satellite to low Earth orbit with SpaceX Falcon 9 costs around $67 million. The cost per kilogram is roughly $2,800 to $3,000. Advances in technology have reduced costs dramatically, allowing even smaller satellites to reach orbit for only a few $100,000. More than 90 countries in the world currently have satellites in space. Out of these, 58 countries have the capability to build their own satellites, while the rest rely on purchasing or collaborating with other nations. Only 12 countries worldwide have the ability to design, build, and launch their own rockets to send satellites into space. These include the United States, Russia, China, Japan, India, Iran, and a few others. As of 2024, there are over 8,135 active satellites orbiting Earth. About 552 are in geostationary orbit and hundreds more in higher orbits. In 2023 alone, approximately 2,664 new satellites were launched, with the majority being small satellites. The United States holds the largest share, responsible for more than 65% of the launches, with SpaceX contributing a large portion. Exploring space with satellites is a testament to human curiosity and ingenuity. Each launch, orbit, and transmission brings us closer to understanding our universe. As we look up at the stars, we are reminded that with knowledge, technology, and determination, humanity can reach beyond the limits of our world.